Right, now we move to Bayesian econometrics. Okay, here I have a very quick question. What is a model? What does it mean by model? You have heard of so many models, right? In microeconomics, macroeconomics, econometrics. In most economics classes, you should have heard of models. So many models, right? So then, what if somebody asks you, what does it mean by model? Okay, what if any high school student asks you what model is? Okay, what is model? Okay, what is model? Okay, here is my answer. Model is a simply data generating process. Okay, that's the model. Okay, this is again, this is data generating process model. Sorry, data generating process. Okay, suppose you believe, suppose you think a model is good, that means you also think that a particular endogenous variable is generated from the process described by the model. Okay. Okay, here. For example, okay. So y is dependent variable. Theta is model parameters. X is exogenous variables. Okay. And this is just model or the model specification. Okay. Because even if the parameters and random parameters and exogenous variables are the same, but they are the specification could be different. I'm going to explain the details later on. Anyway, at this point, the point is theta and x. Okay, once theta and x are given exogenously given, then y is generated. For example, here you have learned the ISLM ADAS model, right? So in this model, what are the exogenous variables? Exogenous variables. The first one, money, right? Money. And investment spending, which is independent of the income and interest rate, right? So there are so that so this is sort of the autonomous investment spending, right? And government expenditure, right? So these are exogenous variables. What are the endogenous variables? Y, output or consumption, and price level, and interest rate. These are endogenous variables. And also the theta is also exogenous. Although this is not a variable. Okay, this is usually fixed, right? For example, marginal propensity of consumption, the impact of interest rate on investment, right? So then x and theta are both exogenous. Given these exogenous variables, y is derived from the model. Y is calculated. That's why we call y equilibrium or solution, right? Solution of the model, right? And this solution of the model or the equilibrium is always a function of what? Function of exogenous variables, exogenous factors. So theta and x, right? So whenever we express the model, whenever we express the equilibrium over the solution, then it should be expressed in terms of exogenous factors or variables, theta and x. And whenever we express the model, not the solutions, it must be expressed by the relationship between among the endogenous variables or exogenous variables. Okay, all right. So then, let's think of the IS curve. In the IS curve, what variables are there? Okay, of course output. Output is there, and what? Interest rate must be there. So right, IS curve is IS curve is structural equation. The structural equation, which is described the structural relation between endogenous variables given exogenous variables, right? So IS curve express the one particular relation between y and r, of course p there, right? What about Eden curve? In the Eden curve, there are also endogenous variables y, r, and price level, right? Given the exogenous money, right? Money stock, right? So the Eden curve is also a structural equation, and ADAS curve as well, right? Of course, sorry, this is typo. ADAS and AD curve. Where is AD curve? There is no independent AD curve. AD curve is derived from what? AD curve is derived from what? AD curve is derived from ISLM curves, right? So actually, there are three structural equations. Because we have three structural equations, we have three endogenous variables. Otherwise, we cannot identify more than three endogenous variables using three equations, right? Okay, right. So this is the model. So if you believe the ISLM ADAS model is good or convincing, then you believe that these endogenous variables are generated from these sort of the structures. Okay, okay, and if you don't agree with the model, that means you don't believe the model, which means that there must be some weakness, or this is not very sensible because there could be some missing variables, right? For example, this ISAM ADS model, this is just closed economy. And if we believe that economies are not closed, economies are open, so then that means there must be at least more than two countries. Then you would not believe the ISAM model. So then you would not use this model for forecasting future output prices or interest rates, right? So this is model. And then the job of the theorist is to calculate or derive the endogenous variables given or from the exogenous variables. This is their job. This is the jobs of the theorists, right? Okay. So here again, in the information of the theorist, they know the true values. They know true values for the parameters and exogenous variables. Given the parameters and exogenous variables, they calculate or they derive the endogenous variables. This is their job. This is what they do, right? And what about the econometricians? The information of the econometricians is different. It's totally opposite. Okay, they know the endogenous variables. Actually, they have the information about endogenous variables, or we say they have the realizations or the observations of the equilibriums. Let's think of the GDP data. GDP data is from where? GDP data from the IS curve, or is from the Eden curve, or is from the AS curve? No, this is the outcome from the equilibrium, right? So we can observe only equilibrium. We cannot observe the output in IS curve and output in Eden curve separately, right? So we can observe only equilibriums. So we have the equilibrium, or we have the observations, right, from the data, and x is still given by exogenously. This is known, right? So the question is at what model parameters these y have been created, y has been determined by economic agents. So I say econometricians estimate the theta using the observations on y and x, right? This is what econometricians do, right? in this class, we are going to do the equilibration's job. Okay, given the observations, so for example, given the prices, given the asset prices, and given the excitation variables, at what parameters these variables are determined. Okay, because this parameter determines what? This parameter determines the relation between y and x. We are going to estimate theta using the relation between y and x. By doing this, we are able to forecast future endogenous variables, so that we can make a very good decision. Okay. And then there are two approaches to estimate the theta. Okay. One is frequentist approach, and the other one is Bayesian approach. Okay. So in the frequentist approach, and actually you have learned the frequentist approach in the econometrics 1. Okay, let's remind the econometrics 1, and then how you consider theta as the how the theta is taken like this. Here in the class you learned that theta is unknown constant, which is very important. This is unknown. Yeah, this is unknown. Okay, we don't know the what theta is. We have no idea what values the theta should have, right? It's unknown, but it's constant. Constant means this is not certain. This is certain something word. Constant, which means, what does it mean by constant? It's not clear very much. It's constant. Then it's something fixed, but it's unknown, like this, right? Okay. In Bayesian approach, in contrast, theta is taken as unknown random variable. It's unknown, and that's why it takes it. That's why it's taken as random variable, like this. Okay. Let me tell you the difference between the frequentist approach and Bayesian approach. For example, this is example I always use. Let's think of heads or tails, coin toss. Okay. I just tossed a coin. Okay. I just tossed a coin, and I just covered it very quickly so that nobody can see it. Okay. So then, this coin, head or tail. This is random, or this is known or unknown. This is known or unknown. Definitely, this is unknown, right? This is unknown because nobody has seen this, right? Then this is random variable or not? This is random or not? This is not random because it has been already realized. Okay, it's realized, but it's just hidden, right? It's realized. It used to be random. Nobody knows. But anyway, this is hidden. The point is that this is hidden. That's why it's unknown. That's why it's unknown. Okay, that's why this head or tail is considered as unknown constant because it's fixed. It's fixed. It's fixed at head or tail, but it's not hidden or covered, right? But before the coin is tossed, the head or tail is random or non-random. Definitely it's random because it's not tossed yet, right? It's not tossed yet. Yeah. And then, so if you try this sort of experiment to any friend of yours, these two ways of questioning, these two ways of questions are different or not? Is there any point to pick one between these two ways of questioning? No, they are equivalent, right? They are equivalent, right? Whatever is hidden or or it's before it's toast. Okay, from the from the from the point of your friends, they are the same, right? So whatever is hidden, whatever is realized or not, as long as it's unknown, as long as it's unknown, in Bayesian approach, it's taken as random variable. Okay, okay. This is Bayesian approach. In frequentist approach, this is just unknown constant. That's why their job is that's what their approach is to that's what their approach is to is like try to make the best guess. What would be the best guess given the data? Okay. In Bayesian approach, the theta is estimated, and its estimate is given in terms of like histogram or mean line variance. Okay. Okay. And then let's take a very quick break.